Hi guys, I'm Ray. Welcome to my magical trick video. Today I'm going to show you how to use my trick to KO this problem without any thinking. So here we go. So let's take a look at this sequence and series problem with maximum mark 6 and belongs to paper 2. Given the geometric sequence 3, 6, 12, and so on, find the general term and the sum of transitive term to active terms of this sequence. So for the first part of the problem is finding the general term. And of course, in order to find the general term, you may just refer to your formula sheet, okay? So from your formula sheet, you can actually see the general term of a geometric sequence is given by U1, which is the first term. And the first term here is actually 3, okay? So 3 times the common ratio all here, and clearly the common ratio is 2. Yeah, 3 times 2 equal to 6, 6 times 2 equal to 12. So common ratio is 2 to the power n minus 1, okay? So if you get this right, you will be awarded A1 for stating the correct first term U1 and also the correct common ratio here, okay? So the next part of the problem is the real deal of this problem. And of course, there are 2 ways to deal with this problem. The first way is the normal way, so which you have to continue to use the formulas in your formula sheet. So the next formula is the sum of the nth terms of a finite GS, right? Given by U1 times R to the power n minus 1 and then over R minus 1, right? So now you can see the U1 here is actually referred to the first term. But now we're actually counting from the transitive term to active term. So eventually, the first term here will be referred to the transitive term. So you guys may start to get confused here for the normal way, okay? As you can see from the screen. Yeah, because now the new first term will be referred to the transitive term. And that's also a deadly trap here for the normal way, which is to find the value of n, right? And n here is actually the number of terms. So the number of terms counting from transitive to active term is actually done by actx minus transitive plus 1. Yeah, most of you guys may have missed out the plus 1 here. So you will get doomed right there, okay? So as some of you guys may come up and said, sir, how to KO this problem without any thinking? Okay, so this is the time to use my Weiwu's summation trick, okay? Yeah, Weiwu's summation trick, okay? So here I'm going to KO this problem by using the summation of the general term trick. So here we go. So the sum will be given by the summation of the general term. And the general term that you have just find is 3 times 2 to the power n minus 1, okay? And now you can actually see we are counting from transitive to active, right? So which means our n here is actually stuck from transitive to the end of active, okay? That is what we want, okay? And of course, if you get this right, you will be awarded M1 for the attempt to use the summation approach. And of course, A1 for staying the correct general term. And of course, another A1 with staying the correct lower limits and the upper limits of the summation. So in order to get the answer, this is the time to use our GDC, okay? So here we go. So just take out your GDC and press AC to start, okay? So now we're using the summation, so you have to press options, followed by calculation, which is F4 here, and then F6 continue, and now you see F3 correspond to the summation, okay? So 3 times 2 to the power n minus 1, and of course n here could be easily typed by alpha x for n, and then minus 1, okay, and then right back in, and so n equal to 20, so alpha x for n again, and then right back in 20, press the upward button, actx, okay, so execute. So now you got your answer. So correct to 3 significant figures will have 9.28 times 10 to the power 26, okay? And now you can actually see you just got the same answer for the normal way. But if you're using my magical trick, you can actually see you can just skip the deadly trap here, the deadly trap for finding the number of terms, and just calculate it without any thinking. So that's all for this video, and I will see you in the next one.